Hi students, welcome to physics class. Today we are going to discuss some important numericals. Numerical number 1. Numerical number 1. In a motion in a straight line. Motion in a straight line. Two trains A and B of length 400 meters each are moving on two parallel tracks. Two parallel tracks with a uniform speed of 72 kilometers per hour in the same direction. With a head of B. Now the driver of B decides to overtake A and accelerated by 1 meter per second square if after 50 seconds, the guard of B just brushes past the driver of A. What was the origin? What was the original distance between between them. Once again, I am repeating the question, my dear students. Two trains A and B of length 400 meters each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction with A ahead of B. Full stop. The driver of B decides to overtake A and accelerated by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? This is the question. Now see, initially this is the train of A. This is the guard. This is the engine. Here is the person. Initially, this is the train B. This is the engine. This is the guard. Here. This is train B. This is train A. Okay, this is the diagram. After some time, A is ahead of B. After some time, A is here. This is engine. This is the guard. Now, B overtake that one ahead. After some time, this is the train B. This is the driver or engine. Here is the guard. Here is the guard. This guard shown his flag to engine of driver A. Now in this case, what is the acceleration? The acceleration A is equal to 1 meter per second square. This is the diagram we imagined. Now go for discussion point by point. Now point number 1 for solution. For train A, U is equal to 72 kilometers per hour. That is equal to 72 into 5 by 18. That is equal to 20 meter per second. Now T is equal to 50 seconds. Now acceleration A is equal to 0. Now S is equal to distance. Which one? Train of A. Therefore train A. Now therefore S is equal to UT plus half A T square. Therefore SA is equal to 20 plus 50, 20 into 50 plus 1 by 2 AT square. A means 0 into 50 whole square. Therefore SA is equal to how much? 1000. It is 1000 meters because it is 0. Okay. Now for time, For train B, U is equal to 72 kilometers per hour. That is equal to 72 into 5 by 80 meter per second. That is equal to 20. U is equal to 20 meter per second. The acceleration A is equal to 1 meter per second square. For the B train, he is increasing his acceleration. The time T is equal to how much? 50 seconds. The distance S is equal to B train SB. Therefore, S is equal to UT plus 1 by 2 A T square. Therefore, SB is equal to 20 into 50 plus 1 by 2 into acceleration 1 into T square. That is 50 whole square. Therefore, SB is equal to 2250 meters. Now, taking the god, of the train B, in the last component, taking the god of the train B in the last compartment, of the train B, it follows that train B, the original distance, between the two trains plus length of train A plus length of train B, that is equal to SB minus SA. What is this one? The original distance between the two trains plus length of train A plus length of train B, that is equal to SB minus SA. Therefore, consider if this is the train A, this is the god, this is the engine, this is the train A in this direction. Here, this is the train B This is the engine. This is the God. Now tell me, what is this one? That is original distance. Original distance between two trains. Between two trains plus 400 plus 400, that is equal 2500, 2500 minus 1000, that is equal how much? 1250 meters. Therefore, original distance between two trains plus 800 is equal to 1250. Therefore, original distance between two trains is equal to 1050 minus 800, that is equal to 450 meters. Therefore, original distance between two trains is how much? 450 meters. Like this, we have to solve the any type of the numerical. My dear students, I hope you understood this numerical. Now we are going to discuss another numerical. So I hope you understood this numerical. Now we are going to discuss another numerical. Now, numerical number 2. On a 2 lane road, car A is traveling with a speed of 36 kilometers per hour. Full stop. Two cars B and C approach car A in opposite direction. In opposite direction. With a speed of with a speed of 54 kilometers per hour each at a certain instant. At a certain instant comma when the distance AB is equal to AC, both being 1 kilometers. B decides to overtake A before C does. Now, what minimum acceleration what minimum acceleration of car B is required to avoid an accident. This is the question. My dear students, once again I am repeating the question. On a 2-lane road, car A is traveling with a speed of 36 kilometers per hour. Two cars B and C approaches car A in opposite direction with a speed of 54 kilometers per each. At a certain instant, when the distance AB is equal to AC, both being 1 kilometer, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? This is the question. Now, solution. Velocity of car A is equal to 36 kilometer per hour. That is equal 36 into 5 by 18, that is called 10 meter per second. Now velocity of car B is equal to 54 kilometer per hour. That is called 54 into 5 by 18. That is called how much? 15 meter per second. Now velocity of car C is equal to how much? 54 kilometer per hour given by examiner. That is called 54 into 5 by 18. That is called how much? 15 meter per second. This is the data given by the examiner. Now relative velocity of car B with respect to car A is given by, that is called C B A is equal to CB minus CA. That is called 15 minus 10. That is called 5 meter per second. Now relative velocity of car C with respect to car A is given by, that is CA is equal CC minus CA. That is equal 15 plus 10. That is equal 25 meter per second. That is equal 25 meter per second. Since AB is equal to AC, that is called 1 kilometer, that is called 1000 meters, which is given by examiner. Therefore time available to B or C for crossing A is given by that is 1000 by 25, that is equal to 40 seconds. Therefore, if car B accelerates with acceleration A to cross A, car A before car C does then once again, if car B accelerates with acceleration A to cross car A before car C does, then U is equal to 5 meter per second. Time T is equal to 40 seconds. Distance S is equal to 1000 meters. Acceleration A is equal to question mark. Therefore, S is equal to ut plus half a t square. Therefore, 1000 is equal to 5 into 40 plus 1 by 2 into a into 40 whole square. Therefore, acceleration A is equal to 1000 minus 200 whole by 1 by 2 into 40 into 40. Therefore, A is equal to 1 meter per second square. So, my dear students, we have to solve the numericals like this. I hope you understood this numerical. Two numericals, whatever I taught in this video. Thank you very much for watching this video.